Okay, this is 1.5, finding equations of lines. There are actually two kinds of equations of lines. So far we've only worked with the slope-intercept form. That's the commonly used one. Y equals mx plus b, where m is your slope and b is your y-intercept. M is always your slope in both of these forms. And that's a good one to use if you know the slope and the y-intercept. But actually, probably more often, you don't know the y-intercept. If you have the graph, you might know it just from looking at the graph. But often you actually know a point that's not necessarily the y-intercept. So if you know a point and you know the slope, it's actually more convenient usually to use this point slope form, which is y minus y1 equals m times x minus x1. And you do need to memorize that. M is still the slope. X and y are your variables, just like they are up here. And x1 comma y1 is any point on the line. And since there are infinitely many points on every line, there's actually infinitely many versions of this point slope form equation of every single line, as you'll see. So this is from your book, How to Find the Slope-Intercept Form. Depends on what you're given, really. But if you have 2 points, you can use those to calculate the slope. You can substitute in the slope and a point and solve for the value of b if you're not given b. And we'll do that. You'll see it's a little bit involved. And then you can write the equation in slope-intercept form. That's step 3, and check by plugging in some points. If you're using the point slope form right here, you can use 2 points to calculate the slope, just like with this version. But if you don't know the y-intercept and you just know a point, you just sub in that point and that slope into the point slope form. You could leave it like this, or we'll solve some of them for slope-intercept form just so you can practice with your algebra and your arithmetic. So let's do an example. We'll actually write this one both ways. We're going to write the equation of the line that passes through the points 4, 3 and 20, negative 17. So for both of those, we need m, the slope. So let's just start by computing m. I'm going to just let this point be my x1, y1, and the second point be my x2, y2. So you should pause this and try to compute the slope on your own. When you compute the slope, it's y2 minus y1 over x2 minus x1. So I get negative 20 over 16. Let's see, I can take a 4 out of both 20 and 16, so that's negative 5 over 4 is the slope. Okay, so now let's do this 2 ways. Let's use the slope-intercept form first, the y equals mx plus b version. Let's put a big line here. Okay, so if we use this version, we now know the slope. We can plug it in. And we know 2 points on the line, but neither of those points are the y-intercept. So if we want to find this version of the equation of a line, we still need b. Okay, but we can solve for b by plugging in either of these points in for x and y, because when you plug in any point on the line, it should make the equation true. I think 4 and 3 are easier numbers, so let's plug in 4, 3 for x, y, and then we'll solve for b. Okay, so plugging that in, let's see, 3 is y and 4 is an x value. So that will give us 3 equals negative 5/4 times 4 plus b. Simplifying, 5/4 times 4, that's nice because the 4's cancel. So then you have 3 equals negative 5 plus b. Well, if you add 5 to both sides, you get 8 equals b. So that's nice. Okay, so now we have it. The equation then is y equals mx plus b, negative 5/4 x plus 8. So that's the equation of the line in slope-intercept form. Okay, let's try the other form. Y minus y1 equals the slope times x minus x1. Okay, so we know the slope. Let's plug in 4, 3 for x1, y1, because that's a point on the line. Remember, x1, y1 up here is any point on the line. Okay, now we're not solving for an unknown variable like we were in the last one. We were solving for b. We're not doing that this time, so we don't want to plug in anything for our variables x and y. We just plug in that for x1, y1, and that's it. We have the equation. Okay, so y minus, let's see, 3 is the y value, equals the slope, negative 5/4 times x minus the x value is 4. Okay, that is the point slope version of a line. That is an acceptable answer. If I ask for, it just says write the equation. It doesn't say what form to write it in. So that's an acceptable answer. Now I want to go ahead and solve it for y anyway so that you can see that these two are actually the same. So if we solve this equation for y, we'll need to distribute the negative 5/4 and move the 3 over. So first let's distribute that negative 5/4, so negative 5/4 times x. Negative 5/4 times negative 4 is going to be positive 5/4 times 4. Okay, again, the 4's cancel. That's great. 4 divided by 4 is 1. And then we can add 3 to both sides. So we get y equals negative 5/4 x plus 5 plus 3. Right, because that's that 5. The plus 3 is from moving this 3 to the other side. So you do get y equals negative 5/4 x plus 8, which is the same thing we have over here. We could have up here actually plugged in the other point, 20, negative 17. Let me show you what that would look like. We plugged in negative 17 for x1, y1 instead of for 3. It would just look a little bit different. It would be y minus negative 17 equals negative 5/4 times x minus 20. Oops. There we go. Okay, so again, that is fine for your equation of the line. But I'm going to go ahead and solve that for y. Actually, you know what? I would do one thing. This minus negative 17 is pretty messy. Let's go ahead and simplify that to y plus 17 equals negative 5/4 times x minus 20. Okay, and if we solve this one for y, just to see, you do get the same thing. I'm going to do two things at once. I'm going to move the negative 17 over and distribute the negative 5/4. Negative 5/4 times positive 20, or negative 20 is going to be positive 5/4, that's a 5, times 20. Then I'm going to move this 17 over, so it'll become negative 17. Okay, simplifying, 20 divided by 4 is 5. So we have y equals negative 5/4 x plus 25 minus 17. And 25 minus 17, oops, 25 minus 17 is 8. So that's a good equation, that's a good equation. All of those are equations of the same line. So notice how you have two different versions here and here of the point slope form, but they're really the same equation. They just look different, right? Because when you solve for y, you get the same thing. Okay. So let's look at another one. Let's use the point slope formula to write the equation of the line that passes through those 2 points. Okay, so now that you know that it does work, hopefully you believe me, we're just going to jump straight to that one and use it because we don't know the y-intercept. But we can first compute the slope, and then we'll know the slope and 2 points. So the slope is m equals y2 minus y1 is negative 31 minus negative 13 is going to become plus 13 all over x2 is 18 minus x1 is 6. Okay, negative 31 plus 13. If you need your calculator, that's fine. I'll type that in here. Negative 31 plus 13 is negative 18. 18 minus 6 is 12. Okay, 18 and 12. I can take a 6 out of both. 18 divided by 6 is 3. 12 divided by 6 is 2. I don't know why we're at 3. Is 2. So that is negative 3 halves for the slope. So then you have two options here. You could say y minus, let's use the first point. Negative 13 is going to become plus 13 equals m, the slope, negative 3 halves times x minus the corresponding x point to the negative 13 is 6. And there's a good answer right there. Okay, but I'll show you the other one. The other one, if you plugged in this, would be y plus 31 equals the slope times x minus 18. And all of you should probably practice solving for y just to practice your arithmetic a little bit. So pause it and practice and then restart to check your work here. I'm going to distribute this 3 halves out, and then 3 halves times, or negative 3 halves times negative 6 will be positive 3 halves times 6. Then I'm going to move that 13 over to the other side. So let's see, 6 divided by 2 is 3. So we have negative 3 halves x, and then 3 minus 13 is negative 10. So a good exercise for you would be to solve this one for y and make sure that you get this. Okay, let's do one of these again. Find the equation of the line that passes through the points in this table. So I'm telling you that these points all lie on a line. Okay, I promise they do. If they didn't, I would tell you to check first. So it doesn't matter which 2 points that we use to compute the slope. You know what, I'm going to use the 2 that don't involve decimals, just because that probably makes it a little bit easier. So I'm going to use those 2 points to compute the slope. So this is my y2, that's my x2, that's my x1, and that's my y1. So computing slope, we have 27 minus 13 over 15 minus 5. 27 minus 13 is 14. 15 minus 5 is 10. So you could use 14 over 10. You could even use a decimal, 1.4. You could reduce this and call it, let's see, you can divide them both by 5. So that's the same as 7 over 5. It doesn't matter. Both of those are good. The reason a decimal is okay in this example is because it's an exact decimal, 1.4. There's not a whole bunch of decimals out here that go on forever. I definitely don't like rounding. When that happens, you're going to get the wrong answers. But it's okay in this case because that is exact. Okay, so with that, now we can pick any point that we want. Let's see, I'm just going to use the first one, 5, 13 as the x1, y1. Okay, let's start by writing this. Write this every single time until you have it memorized. Y minus y1 equals m times x minus x1. So if we plug in 5, 13 for x1, y1, we have y minus 13 equals the slope m, 7/5, times x minus x1 is 5. Okay, you can leave it like that because it doesn't say to solve for y, but I'm going to go ahead and solve for y. If on WebAssign it asks you to solve for y, well then you've got to solve for y. If it doesn't specify, it just says write the equation, then it should accept this. Okay, so solving for y, we distribute the 7/5 and add 13. So that gives us 7/5 x. Nice, the 5's cancel. negative 7 plus 3 is going to be negative 4. Okay, there it is. It would be a good idea for your practice to try writing this point slope form with a different point on the line and then solve it for y and make sure you get the same thing. Okay, let's just do another different example. Different way of looking at it is if you have the graph. What if you have the graph and you want to find the equation? I mean, you can, honestly, you do this however you know to do it, whatever seems easiest to you. It's not about finding the easiest way, it's about finding a way that works. So what I see when I look at this is that I can just read off the graph pretty clearly and easy what the y-intercept is. So that tells me that b is 10 because the y-intercept is 10. It's also very easy to read off some points on the line. But if you know b, it might make the most sense to use the y equals mx plus b form, at least if I can figure out the slope from the graph, which, let's see, looks like I can, because to find slope, you know, remember slope is rise over run to get from one point to the next. I can clearly tell it goes through this point 0, 10. To get to the next point, I just need to go down 5, right 2. Looks like it definitely goes through that point right there. So I went down 5, right 2, which means the slope is negative 5 over positive 2. Okay, just from reading it straight off the graph, right? And you can check here. You go down another 5, right another 2 units, and you hit another point on the graph. Another way to think about it, let's show you over here, is if you're at this point, you actually go up 5, left 2. Okay, that corresponds to putting the negative on the denominator, right? Because then this means up 5, your rise is positive, so you're going up, and your run is negative, so you go left. So you go up 5, left 2. Either way, it's the same. So that's actually enough information to write the equation right there. So your slope is negative 5 halves times x plus the y-intercept of 10. And there's an equation. Okay, let's do an applied example. We'll actually do a couple of them. Here we go. So a business purchased a production machine in 2005 for $185,000. For tax purposes, the value of the machine in 2011 was $129,500. So looks like the value went down because they bought it for $185,000. Now the value is less than $130,000. So if this business uses what's called straight line depreciation, it says write the equation of the line that gives the value of the machine based on the age of the machine in years. So straight line depreciation, what that is a way to model the value of things that go down over time, or objects whose values decreased over time. Machines, computers are a common example, right? You buy a computer now, maybe it costs you $500. But in 3 years it's probably only worth maybe $150. The value goes down over time. Cars are the huge example that most people are familiar with, right? You buy a car for however much off the lot, $30,000 or something, right? And then as soon as you drive it off the lot, it loses at least $5,000 right there, and it continues to lose value over time. So, anyways, you can use a straight line to model that. Straight line depreciation just means it depreciates, which means it loses value over time. And this just means you're going to use a straight line to model what it's worth over time, assuming that it loses value at a constant rate. Okay, so if we're going to write an equation that gives the value of the machine based on the age of the machine in years, and that means right there means that our x is going to be age of the machine. So let's just call it A. Let's just let A equal age of the machine. You do have to define your variables if they're not given to you. Okay, so that means when we have a little axis over here that we're going to have age on this axis, an A. Let's see, for the y's, what do we want to call that? That's the value, the money, the value. I'll probably put Let's use V for value. That makes sense. Here we go. Okay, so V is going to be value over time. Okay, now let's go write these numbers as coordinate points. Okay, so if the business purchased the machine in 2005, then its age in 2005 is 0, right? It's brand new. So a coordinate point on the line here would be 0, 185,000. That is an A, V point. Then that would mean in 2011, it's 6 years old, and its value is 129,500. Okay, so with that, we have 2 points, right? We can compute the slope. Doesn't matter which version of the equation of the line you use, you still need the slope. So let's compute slope using those 2 points. So let's use this as my y2, y1, and I'll use that as my x2, x1. So y2 is 129,500 minus 185,000 over 6 minus 0. Okay, 129,500 minus 185,000 is negative 55,500 divided by 6. Let's see what happens when we divide that by 6. We get negative 9250. Nice. So my slope is a nice whole number. Okay, so using, let's see, you know what, let's go ahead and use, actually in this case, we do know the y-intercept, right, because we're given it right here. When A is 0, V is 185,000. That's this point on the line up here, right? 185,000. That is the y-intercept. So B is 185,000. So we can use slope-intercept form. Y equals mx plus b. Okay, so there is except we're not using x's and y's, we're using a's and b's. So V equals negative 9250 A plus 185,000. Okay, that's in a line that models the value over time. Okay, so with that, let's come back down, there we go. So with that, what is the slope of the equation? Well, the slope is, we can just read it off, right? Slope is negative 9250. But the real question here is, what does it represent in regard to the value of the machine? Well, you know what? Let's look at this over here. If A, this is just some exploratory math here. If A is 1, let's plug in A equals 1 and see what happens after 1 year. Okay, then V would be negative 9250 times 1 plus 185,000. So 185,000, I'm going to calculate that value right here. 185,000 minus 9250 is 175,750. Of course, that's in dollars and everything. But the point is, how much did it go down? It decreased from its original value, right? We did 185,000 minus 9250. So in that 1 year, it decreased by 9250. Now let's see how much it decreases in the second year. In the second year, the value is negative 9250 times 2 plus 185,000. So negative 9250 times 2 is negative 18,500 plus 185,000 gives me 166,500. So it's going down, right? It's going down by the same amount because if I subtract, what is 175, 750 minus 166, 500 to see what the difference is between these 2 years right here, this year and this year, we get 9250, right? So it decreases by the same amount every year. That's what slope means, right? It's the rate of decrease. So in regards to the value of the machine, this tells us that the value of the machine decreases, and it's decreasing because the slope is negative, decreases by $9,250 every year, at least on average. All right, so that's what straight line depreciation does. It causes, or it's a model that assumes that it decreases by the same amount every year, every day. Okay, what is the vertical intercept? That's the y-intercept, right? We already talked about that. So that's 185,000. What does it represent? Well, that's the initial value, right? That's 185,500 right there. So the dollar amount, $185,500, is the initial value of the machine. Okay, so there's an applied example with lines. We've done some of these before. This is just extra practice for you, really. Oh, one more that I forgot about. What is the horizontal intercept of the equation? Ooh, that one's more interesting. We haven't found that yet. What is the horizontal intercept? That would be, up here I didn't draw it, if we keep going up here. Where does it cross? All right, that's your horizontal intercept, your a-intercept. It occurs when the value is 0, right? V-intercepts occur when a equals 0. A-intercepts occur when this value v is 0. So let's go, you take the equation of the line. Down here, here's the equation of the line. V equals negative 9250 A plus 185,000. So the horizontal intercept, or A-intercept, occurs where V equals 0. So I'm going to sub in V equals 0 here and solve for A. So solving for A, I'm going to, actually in this case I'm going to add 9250A to both sides. So a positive 9250A equals 185,000. And then divide both sides by 9250. Let's see, what is 185,000? 185,000 divided by this 9250 gives me exactly 20. That's cool. 20. So that means that V equals 0. So V equals 0 at A equals 20. So we need to interpret that into a sentence, right? What does that actually mean? So that means that, you say therefore, 3 dots means therefore. Therefore, the value of the machine is 0, right? V equals 0 means the value of the machine is 0 when A is 20, when its age is 20. So after 20 years, it is obsolete technology at that point. Okay. So there's an example. What I recommend you do at this point is pause this video and try this one on your own. Okay. Then after that equation, we're going to move on to parallel and perpendicular lines. We'll do a couple of those and then one more applied equation there, just to wrap things up and really nail in the applications. So, according to this website, the number of newly diagnosed AIDS cases for adolescents 13 to 19 years old in the United States was 310 in 2000 and 458 in 2003. Assume that the number of cases is growing at a constant rate. Okay, and write an equation to represent this situation. So if the rate is growing at a constant rate, that means that we can use a linear equation to model the growth. So let's see, we need to define some variables here. So let's draw a little axis here. Let's see. So let's see. We have the number. Read the question over and over again, by the way, until you understand it. So the number of newly diagnosed AIDS cases for adolescents was 310 in year 2000 and 458 in 2003. So there is a couple ways we could do this. One way would be to let the year be, well, year's going down here, right? That's the independent variable. The number of AIDS cases, let's put AIDS cases, I should probably write that backwards, depends on the year, right? So that's the dependent variable. It's going to go up here. The question is, what letters are we going to use, and how are we going to find year? I mean, you could put 2000 as being an x value, but then you're way out here on the x-axis. Since the data starts in 2000, I would probably call this right there year 2000, and let's call this, there we go, let's call this, I don't want to call it y, but for years, because y is usually this axis, so that would be really confusing. So let's call it, let's just call it x. So, and x is going to be years since 2000. So when x is 0, that is year 2000. When x is 3, that's year 2003. And then for these numbers, I think we just leave them 310 and 458. So we need to explain that by saying, let's let x equal the number of years since 2000. You do have to define your variable like that. Okay, and then for this one, we could call it, you could call it A for AIDS. I think since we're using X, let's just go ahead and use Y. Let's let Y equal number of AIDS cases. Okay, so then we know that in 2000 there were 310 cases, so the coordinate point corresponding to that data would be 0, 310, and the coordinate point corresponding to this data is 3, 458, because 2003 is year 3. Okay, so I do know my y-intercept. You can just read that off, right? That's right there. When x is 0, y is 310. So there it is. Okay, and then since I do know my y-intercept, I'm going to go ahead and use the slope-intercept form and just find the slope. So slope is y2 minus y1, so 453 minus 310 over x2 minus x1 is 3 minus 0. 453 minus 310, let's see, 3 minus, you can do this without a calculator. 3 minus 0 is 3, 5 minus 1 is 4, and 4 minus 3 is 1, divided by 3. 143 divided by 3 is not an exact number. Okay, so let's just leave it as 143 over 3. Right, that's not gonna, we don't want to round that. Okay, so there's the slope, and I know the y-intercept, so my equation is y equals the slope 143 over 3 times x plus my y-intercept is 310. So there is my model, my linear model. What is the slope we just found? Slope is 143 over 3. Here, let's go ahead and approximate it. Now, to write approximately, you put a little wavy equal sign, because we're going to talk about what the slope means, which means we need to have a real number, probably a decimal number, to explain it. This means 47.6 repeating, or 47, let's just round it to 2 decimals. 47.67 is fine. So what that means is how fast it's growing, right? That's the rate at which it's going up. It's got a positive slope, so it's going up by 47 2/3 cases every year. So that means on average, and you can't actually have a 2/3 case of AIDS, but on average, the number of AIDS cases with these adolescents increases by about 47.67 every year. Okay. And now let's look at the vertical intercept. So the vertical intercept is right there where it crosses, 310, right? So the vertical intercept is 310. It's not letting me write. There we go. So vertical intercept is 310. Or if you wanted to write it as a coordinate point, that's the coordinate point 0, 310. So that means that's the initial number, at least in 2000, right? That means in 2000, or in the year 2000, there were 310 cases. Okay. Let's look at parallel perpendicular lines, and then we'll come back and we'll do one more applied problem. I'm not really sure it's even necessary to work it, but I'll do it for you guys just in case you want to see it. So parallel and perpendicular lines. Let's talk about this. Two lines are parallel if their slopes are exactly the same. Right? Notice those have the exact same steepness. That's what it says right here. Two lines are parallel if their slopes are equal. You could say this one has a slope m1, this one has the slope m2, and they're equal. Two lines are perpendicular if their slopes are opposite reciprocals. I usually call them actually negative reciprocals. This is from your book, but I would call that negative reciprocals. The word opposite isn't as clear. A reciprocal is what you get when you flip a fraction upside down. So if this one, the blue one, say has slope m1, then the red one has slope -1 over m1. All right, they're opposites and they're negatives. So just as a quick example, for perpendicular, if one slope of a line is, let's say it's 3, okay, then a line perpendicular, it's a shorthand for perpendicular, to it has slope. Well, you have to flip the fraction. 3 is not a fraction, but if you think of it as 3 over 1, right, then it is. So you flip it to get 1/3, and you make it negative. One's going to be positive, the other one's going to be negative. Okay, so let's start with the perpendicular. Let's write the equation of the line that goes through the point -12, 8, and is perpendicular to the line y equals 4x minus 23. Okay, so there's two lines going on here, right? We want the equation of a line that goes through this point, but that's perpendicular to this line. So this line has slope 4. If you just start writing m equals 4, it gets confusing. Well, which m is 4? This line or the line we're trying to write? Right, so that line has slope 4. So the line that we're going to write the equation of, our line, has slope, flip it 1/4 and make it negative, so -1/4. And our line goes through this point, -12, 8. I don't know the y-intercept, so I'm going to use point slope form. So y minus 8 equals the slope times x minus -12 is that. Let's go ahead and solve this thing for y. So y is -1/4 times x, and you can do this in your head for sure. -1/4 times 12, that's 12 divided by 4 is 3, so -3. Then I'm going to move the 8 over, so plus 8. So we get y equals -1/4 x plus 5. It's the equation of the line, and you can check by graphing, which actually I think would be a good idea. I'm going to open up my grapher here. You can use your graphing calculator to do things like this just to see. It's kind of fun to see, are they really perpendicular? And you can check. So the first line we were given was y equals 4x minus 23. Okay, I must be, yeah, I'm too zoomed in. I gotta zoom out because -23 is way down there. Okay, so there's that line. Now let's draw our line. We got, what did we get? -1/4 x plus 5. -1/4 x plus 5. Yeah, they look perpendicular to me. Okay, now on your calculator, you might not always have a perfectly square scale, so you might have to change the scale to make it square to make it look perpendicular. Because if your y-axis is like more squished than your x-axis might be more stretched out a little bit. It's going to look a little bit off, but anyways, that's a good way to check, is just visually. It's kind of cool. Okay, let's do a parallel example. Let's write the equation of the line that goes through the point 8, 11. That is parallel to the line 5x minus 2y equals 30. Okay, so it's parallel to this line, so our lines are going to have the same slope. So I need the slope of this line. I need the slope of that line right there. Probably the easiest way to get it is to solve it for y, and then that way it'll be in, or put it in y equals mx plus b form, so that we can just read off m, the slope. So in solving that for y, let's move the 5x over, so I'll have negative 2y, just use color, so I'll have negative 2y equals 30 minus 5x. Then I divide both sides by 2. Okay, I noticed a lot of people had trouble with this arithmetic. Over negative 2, there we go. So to write this in slope-intercept form, we need to split this into two separate fractions, 30 over negative 2 minus 5x over negative 2. Right? I'm just unadding the fractions. And then simplify from here. 30 over negative 2 is minus 15. These negatives are going to combine to be positive, and let's just write that as 5/2 times x. And then there it is, that's slope-intercept form right there, 5/2 x minus 15. So now we can read off the m. That's our slope m of this line, but we're writing an equation of a line that's parallel to that. So for our line, yeah, the slope is still m, 5/2, and we know it goes through the point 8, 11. I don't know the y-intercept again, so I'm going to use y equals mx plus, oh no, sorry, y minus y1, point slope form, equals the slope times x minus x1. And let's plug in what we know. So y minus 11 equals the slope, 5/2 times x minus 8. So we could stop there, but let's solve for y. So y equals 5/2 x. We do 5/2 times 8. I'll write that out. 5/2 times 8. You want to practice doing this in your head because 8 divided by 2 is 4. That's fairly straightforward. And then moving the 11 over gives me plus 11. So I've got y equals 5/2 x. 5 times 4 is negative 20 plus 11. So y equals 5/2 x. Negative 20 plus 11 is negative 9. Okay, always box your answer, by the way. And let's graph both those lines. So the first line is y equals 5/2 x plus 15. Now that's assuming I did all of this work correct, but I'm pretty sure I did. So 5/2 x minus 15. Let's go change this one. That's not the right line. We got 5/2 x minus 9. Alright, so they are parallel. They have the same slope there. Just different points, different y-intercepts. Okay, so that's parallel and perpendicular lines. I think that's enough for you to get it right there. I think this is a really good example, and I do think you should try it. Definitely pause the video and try it first. But I'm going to go ahead and work it just in case you need it. There were 44.1 million major home appliances shipped in the United States in 2007. In 2009, only 36.7 million were shipped. Write an equation for the number of major home appliances shipped in the United States T years since 2000. Okay, this one is giving me the variable. So T is the number of years since 2000. You might want to write that out. I'll just underline it. Okay. So write an equation for the number of major home appliances. So I'm given one variable, my T, right? I'm told this is, the years is going to be T's. I am not given this variable. I can call it whatever I want. I'm going to call it A for appliances. Okay. A for appliances. So we need to write that out. Let A equal the number of appliances shipped in that year. Okay, so let's see, we do have 2 points on the line. If T is years since 2000, let's see, I am given data for the year 2007 and for the year 2009. So neither of those is the year 2000, right? That's year 2000 right there. So I am not given the y-intercept. Okay, but let's write these two pieces of data as points. I know that in 2007, that's when t is 7, there were 44.1. Rather than actually have a bunch of zeros, let's just put over here, let's say this is, I'm going to try to write sideways, appliances in millions. There we go. It's kind of hard to read. It's really hard to write sideways on this digital pad. Okay, so that's 7,44.1, and the other point I know is 2009, so that's 9 years since 2000, 36.7. Those are 2 points on the line. Okay, so let's see, putting this together, I've got to compute slope, right? So my slope is, let's do this as my second point. So 36.7 minus 44.1 over 9 minus 7. Okay, definitely let's use a calculator for that. 36, come on, there we go. 36.7 minus 44.1 is negative 7.4 over 2. Let's see what that does. Negative 7.4 divided by 2 is negative 3.7. That's fine. It's an exact decimal, so let's just go with that. I don't know the y-intercept, so I'm going to have to use point slope form. So again, write this. Oops. General form every time till you memorize it. Y minus y1 equals the slope m times x minus x1. Okay. So I can use either of these 2 points. I'll just go with the first one. So y minus 44.1 equals the slope times x minus 7. And let's go ahead and solve that for y because we're going to need the slope in part B. So it's y equals negative 3.7 times x, negative 3.7 times negative 7, we'll figure that out in a second, plus 44.1. Let's see what all of this simplifies to. So I need to do, oops, I'm trying to do it where you can see it here. Here we go. So negative 3.7 times negative 7 plus 44.1. Oh, I guess I have to put times. There we go, is exactly 70. So this is y equals negative 3.7x plus 70 is the equation of the line. Oops, except I switched over to y's and x's without even thinking about it. So let's write it with a's and t's. So a is negative 3.7t plus 70. That's my real equation. Okay, so what is the slope? Well, the slope is negative 3.7. And what does it represent? Well, let's see. If it's, that means there's, it starts up here, right, and it goes down. I don't know if it really, it's not really probably ever going to intersect the axis, but what does it represent? That's the rate at which it goes down, right? So that means every year 3.7 million fewer appliances are shipped. So 3.7 million fewer appliances are shipped every year. They can only go on for so long, right? It's probably already changed. What is the vertical intercept? That's this right here. That's the y-intercept right there, B, 70. So it is 70, which means in right here in the year 2000, 70 million appliances were shipped. So in the year 2000, 70 million appliances were shipped. Okay, so I hope that helped with all the applied examples and everything. You just got to practice with those. So with this, you should be set to go work on your homework.